Every beam in every building is fighting three invisible enemies: bending, shear, torsion. Ignore them, and even the strongest beam can crack, twist, or collapse. Today we're breaking them down with brutal simplicity. 1. What is a beam actually doing? A beam isn't just a piece of concrete or steel. It's a force-resisting machine. When loads act downward, the beam tries to bend, sag or hog, slide internally, twist, torsion. Engineers design beams by checking all three. Miss one, you fail. 2. Bending, flexure. When a beam is loaded, the top fibers compress and the bottom fibers stretch. This creates bending moment. Key points. Maximum bending occurs where shear becomes zero. Compression zone on top, tension zone at bottom, in simply supported beams. Reinforcement goes where? In tension, because concrete is weak there. Failures to remember. Sagging cracks, bottom surface. Hogging cracks, top surface. Bending decides your beam depth and tension steel. 3. Shear, the silent killer. Shear force tries to slide one cross-section past another, creating diagonal cracking. Key points. Maximum near supports. Diagonal cracks equals classic shear failure. Ties, stirrups resist it. Exam trap. Shear failures are sudden, no warning, most dangerous. This is why stirrups are non-negotiable. 4. Torsion, twisting. Torsion appears when beams are loaded eccentrically or part of a frame corner. Key points. Causes spiral helical cracking. Needs special torsional reinforcement. L-shaped beams, staircases, and edge beams often face torsion. Most students ignore torsion. Real structures don't. 5. How all three work together. Real-world insight. A beam rarely faces only one. Load conditions create combined stresses. Bending shear, bending torsion, shear torsion. Sometimes all three at once. The critical case decides your reinforcement layout. Practical example. A beam supporting a cantilever balcony faces bending from self-weight, high shear near the wall, torsion because load acts off-center. If torsion is ignored, the beam twists, cracks, balcony sags. This happens in poorly designed apartment buildings all the time. If you understand bending, shear, and torsion, you understand 90% of beam behavior. This is the heart of structural engineering.